Welcome to video number 8. This video was entirely inspired by this afternoon picking some rhubarb. And when I was picking the rhubarb, I couldn't help but remind myself of how amazing rhubarb is. For those of you that don't have rhubarb or any experience of rhubarb, rhubarb first of all is completely resilient. You can't get rid of it. No matter how much you dig it up, it always seems to come back the next year. But secondly, it's one of these plants that has this really nice feature that when you pull the stems off and you really want to eat the stems, really nice crumble. If you cut off the leaves, which otherwise would be wasted, you can boil them up and then use them as a pesticide. It's quite potent. It's like cyanide for caterpillar, and it will mean that the next year your crop or the following set of stems that come out, you can spray the cyanide on, and you get a really nice bumper crop. And I thought, wow, there's quite a few mathematical results that seem quite similar. So sin x, cosine x, those trigonometric functions are very cyclic. They go round. They do something very similar when you apply calculus to them. So if you differentiate sine a couple of times, eventually you'll get back to sin x, and same with cosine and various other trigonometric functions. And there's other functions that have similar properties. E to the power x immediately differentiates back to itself. Really nice features, and there's an example that I use with my C4 students when they're learning integration by parts. And if you know how to integrate by parts, I strongly suggest you try this example. Or if you're keen and want to look it up, then it's quite a nice thing to do. Here it is. The integral of ex times sin x. When you integrate this by parts, it's one of these questions that doesn't appear like it gets any better, and in fact, unless you spot how perfectly cyclic this thing is, you'll find yourself in this loop that repeats and repeats, getting longer and longer each time, kind of like my rhubarb. And by spotting the repeat, you can force it to stop. It's a very clever example. So if you have a go on that, and if you get stuck and you want to put a comment in, then I can point you in the right direction. But there's also loads of things on the internet to help you with an example like this. Now, my puzzle today is quite a lot simpler than that. I'm not going to expect any GCSE students or students just coming to Western College to try and solve that. That'd be ridiculous. But on the FX83 GT, there is a function on here that has a similar kind of effect as what that function does. It's a really simple function, and I'll describe it by its effect. See if you can find out what the function is, and then I've got another puzzle as well, really short puzzle. So what this function does is, if I tell my calculator an answer, so I've just typed in 54 there, I'm going to use the answer key then to put that number back into the function that I'm going to type in. Obviously I'm not going to show you what that function is. I want you to try and work that out. When I press answer, once it's in the function, it gives me a value which is not 54, it's something different. Then I press it again and I get back to 54, obviously covering up the solution. Now this works. I could do the same thing with 9. So if I start off with 9, type answer, use the function I want to use, press it once, something different, press it twice, and I get back to, again to show you that I'm not cheating, 9. And there's only one value I can type in on the calculator where that doesn't work. There's only one value where this function doesn't have that property. So perhaps that will give some people a clue as to what the function is. But anyway, good luck finding that one. And if you find any others that wasn't this one, I'd like to hear about what those ones were as well. Always interested. And if you put your answers in the comments below, I'll look forward to reading them.